last thing that we will be doing is completing the information that the degree of function started by giving us the shape of the graph. So when we know the sign of the leading coefficient, not only are we going to know the shape of the graph from the degree of the polynomial function, but if that leading coefficient is positive, it will also tell us the orientation of that graph. So just like with the previous video, I have done these or a schematic view of these tables on a piece of paper. So if you want to stop the video and do the same, feel free to do so. So not even that, like look how simple I've done this. So I said, okay, the sign of the leading coefficient will tell me the orientation of the graph. And on the left hand side, I put linear, degree 1, quadratic, degree 2, and cubic, degree 3. And now I'm going to talk about a positive leading coefficient and a negative. This is a plus and a VE. This is a negative and a VE. This stands for a shortcut to positive. And this is a shortcut to negative. A little bit faster to write. So we're talking about the positive leading coefficient, LC for leading coefficient, negative leading coefficient. Now, I've already given you the orientation for all of the positive leading coefficient, but I'm going to give you a little bit more detail to that in terms of what we call the end behavior of the graph, the orientation of the graph. If you want to be very specific about it, we call it the end behavior, and we are referring to how the graph starts and in which quadrant and where the graph ends, which quadrant. Okay, so any linear graph with a positive leading coefficient of its equation, it will look like this. It's an increasing. Remember, you can use the word increasing for the linear function. Just to be safe, use it only for the linear function. And the end behavior, you can say starts in quadrant 3 and ends in quadrant 1. So this is quadrant 3. If you don't remember the quadrants, we can see if this pen works. My red pencil won't work anymore. Nope. How about blue pens? Yeah, so 1, 2, 3. Whoops. 1, 2, 3, 4. So it's quadrant 1, quadrant 2, quadrant 3, quadrant 4. Sometimes we write them with Roman numerals like this. 1, 2, 3, 4. Okay, doesn't matter which way, it's fine. So it starts in quadrant 3 and ends in quadrant 1, except for the constant function, but that's just a special case. The negative leading coefficient graph, it will be a decreasing graph. So if you know that you have a linear function, and if you look at its equation, it has a negative leading coefficient, the graph will be a descending graph. And that one for end behavior starts in quadrant 2 and ends in quadrant 4. Start in quadrant 2 and in quadrant 4. That's the end behavior of the graph. A quadratic, and I've already given you the positive leading coefficient version, is a parabola upwards. Let's make it green so it's prettier. Parabola upwards. Okay? Now let's describe the end behavior. I'm going to do it in blue. End behavior starts in quadrant 2 and ends in quadrant 1. And in quadrant 1. For a negative leading coefficient, we're going to have a parabola down. And this is the one that we haven't seen. And this is a new piece of information. Of a negative leading coefficient for your quadratic function, it will give you, you can expect this shape. So not only a parabola shape, but also orientation. It's downward. the end behavior starts in quadrant 3, ends in quadrant 4. And cubic is the last one we do. All of the examples I've given you for the shape of the graph, they're all positive leading coefficients. So it starts in quadrant 3, ends in quadrant 1. And for negative leading coefficient, you're going to have it going the opposite. So it starts in quadrant 2, ends in quadrant 4. If you go back to linear function, you'll see that the end behavior is exactly the same, just the shape of the graph differs. So it starts in quadrant 3, ends in quadrant 1. And for the negative leading coefficient, starts in quadrant 2, ends in quadrant 4. And that completes all of the information. So just a little bit of a quick recap. We started with the degree of the polynomial function. So I'll zoom out a little bit very quickly. Degree will tell you the shape of the graph, but not the orientation. For getting the orientation, you need to know the sign of the leading coefficient. So just the shape, a line, a parabola, or this snake graph. It will also tell you the number of possible x-intercepts, and it's always equal to the degree. So if you have linear, it's going to have, or you can expect to have 1 x-intercept. If it's a quadratic, degree 2, you can expect up to 2. Not necessarily 2, but up to that point, up to 2. And for 3, you can expect up to 3 x-intercepts. And the last information from the degree of the function is how many turning points you can expect. So for degree 1, 0 turning points, for degree 2, up to 1 turning point, and for degree 3, up to 2 turning points, but in actuality is 0 or 2. The next piece of a equation characteristics, it will be the free term, and that's going to tell us about the graph, the y-intercept of that graph. And the third thing that we can take from the equation, so an equation characteristic, is the sign of the leading coefficient, and that's going to tell us the orientation of the graph, and fancy for orientation will be the end behavior. How does the graph behave at its ends? If it's a linear with a positive leading coefficient, the graph starts in quadrant 3 and ends in quadrant 1. If it's a negative leading coefficient, the graph starts in quadrant 2 and ends in quadrant 4. If it's a quadratic with a positive leading coefficient, you start in quadrant 2 and end in quadrant 1. If it's quadratic with a negative leading coefficient, start in quadrant 3, ends in quadrant 4. And if it's cubic, starts in quadrant 3, ends in quadrant 1, just like the linear function with the positive leading coefficient. And this one, it's a cubic with a negative leading coefficient, starts in quadrant 2 and ends in quadrant 4. Okay? If we are to generalize a little bit, all the time when you have an odd degree polynomial, like linear, like cubic, degree 5, degree 7, the end behavior is always going to be the same. Just in between, the graph will look like you will have more x-intercepts, more turning points, or more hills and valleys as the degree goes higher and higher. If you have a polynomial of degree 2, 4, 6, so all of the even degrees, they behave the same at the end. So they have the same end behavior. Just in between, you have more hills and valleys. So you're not going to have a vertex only. You're going to have multiple turning points, up, down, so multiple hills and valleys. But at the end, you know you can have either an upward ending or a downward ending for the even degree polynomials. Let's do exercise 2, and hopefully we'll have time to do number 3. So use the equation of the polynomial function f of x equals negative x cubed minus 8x squared plus x plus 42 to answer the following question. And justify your answer means saying how do you know that. for the first one, part A, how many x-intercepts, sometimes called zeros, could you expect for this function? Well, for finding out the number of x-intercepts, which is a graph characteristics, you have to look at the degree of the function. The degree of this function is 3. Okay, so you can expect up to 3 x-intercepts because the degree of the function is 3. That's how I know. So the part of the sentence after the because is giving the justification of your answer. How many turning points you can expect from this function, for this function? You can expect up to 2 turning points, 0 or 2, so you can be even more specific. Why? Because it's always 1 less the degree of the function. So you can do 3 minus 1 equals 2. What is the y-intercept? For this one, I ask you not how many, but actually what is it? So the y-intercept is coming from the free term. So the y-intercept, you can say, is at 42 because the free term is 42. And then the last thing you have to do for this question is describe the end behavior and sketch a possible graph. The end behavior of the graph. First of all, you need not only to know the shape of the graph, but also its orientation. And those two pieces together will tell you the end behavior. Why? Because it really matters if you're talking about a linear function or a quadratic, right? They won't have the same end behavior. So you can't just look at the leading coefficient, okay? So, because you don't have any explanation for that one, just no justification, I will justify it for you here. So for this last piece here, for D, why is it decreasing from quadrant 2 to quadrant 4? So you justify it as following. You say the type of function, so you say the function is degree 3 function, or you can say it's a cubic function, or you can say cubic. Okay, and you can say what type of leading coefficient. So you can say negative leading coefficient. Those two pieces of information together will tell you that the graph shape is a cubic, a snake graph, but it's a negative one. So it starts in quadrant 2 and ends in quadrant 4. So starts in quadrant 2, ends in quadrant 4. Okay? Because it's a cubic function with a negative leading coefficient. So you do have the explanation right there. Actually, you didn't really notice that. There you go. That's the shape of the graph you can expect, and this is its end behavior. Okay, so that's how you do these questions. I think in exercise number 3, we have quite a bit of work to do here. Let's see. Yeah, we have 3 of them. And we are asked to figure it out, the number of possible x-intercepts. Okay, stay there. I don't wanna